A cargo plane crashes just seconds after takeoff. A massive fireball engulfs it. And worst of all, it hits a shopping center, killing innocent people on the ground. Everything was caught on camera from multiple angles. How could this happen if aviation is the safest mode of transport in the world? And why have all aircraft of this model now been grounded? Today on TechCurio, we bring you the full analysis of the crash that could mark the end of one of the most iconic aircraft in modern aviation. The MD-11. On November 4th, a cargo plane operated by UPS crashed in the United States just after takeoff. The plane was not only completely destroyed, but ended up crashing into a group of shops and businesses near Louisville Airport in Kentucky. Flight facts: airline, UPS, cargo transport. Model, McDonnell Douglas MD-11. Origin, Louisville Airport, Kentucky. Destination, Honolulu, Hawaii. Estimated distance, 7,000 kilometers. Preliminary cause, engine failure during takeoff. The aircraft was fully loaded with fuel. Why? Because of the extremely long route. That's what made the explosion even more intense. The plane starts its roll down runway 17R. It accelerates, gains speed, and just at the end of the runway, it lifts its nose. But immediately after, it loses altitude, tilts, and crashes. The result? A massive explosion. 3 crew members killed. 5 people on the ground killed. A large section of a shopping center completely destroyed. Initial observations. In the footage, fire is clearly visible on the left wing during takeoff. The aircraft manages to lift off, but doesn't gain altitude. Later confirmed. Engine number 1, left, detached from the aircraft. The NTSB, the U.S. National Transportation Safety Board, confirmed this hours later. Engine number 1 separated from the wing and remained within the airport perimeter. Looking at the altitude graph, we see that the aircraft barely climbs a few meters before rapidly losing height. This matches the videos. But here's what's most concerning. The speed reading remains relatively constant. What drops is lift. Something prevented the aircraft from continuing its climb. And that something was far more serious than a simple engine failure. The MD-11 marked an entire era in aviation. Designed with 3 engines, 1 on each wing and 1 in the tail. It was a technical solution for a time when engines weren't as reliable as they are today. MD-11 facts. First flight, 1990. Purpose, long-range transport. 3 CF6 engines, built by General Electric. Crew, 3. This aircraft had been in service for over 30 years. Today, the MD-11 is virtually retired from passenger service. Only cargo airlines like UPS, FedEx, or Western Global Airlines still operate it. The NTSB confirmed in a press briefing what many had already suspected. The plane's left engine detached from the wing during takeoff. Key details. The separation occurred seconds after applying takeoff thrust. Engine number 1 fell within the airport perimeter. The pylon, the structure that connects the engine to the wing, separated along with the engine. This is important. The pylon is a critical component. It not only holds the engine, it also transfers loads, vibrations, and connects hydraulic, electrical, and fuel lines. NTSB conclusion. Most of the pylon remained attached to the engine when it separated from the aircraft. This suggests a failure in the connection between the pylon and the wing, not between the pylon and the engine. Not between the pylon and the engine. Let's break this down. The engine isn't bolted directly to the wing. It hangs from a pylon. Key components: the pylon has 2 structural mounts, front and rear. These joints support the full weight of the engine, plus dynamic forces during flight. A failure here is critical and irreversible. If one of those joints fails, the engine can detach. And that's exactly what happened. The MD-11 is designed to keep flying with two engines. In fact, all commercial planes are built to continue takeoff if one engine fails after V1 speed. So why couldn't this plane keep flying? New visual evidence. In another video, an abnormal flash is seen from the tail engine, engine 2, just after the left engine detached. What might have happened is this. The fire and debris from the left engine moved toward the tail engine, which may have inhaled fragments or flames, causing a compressor stall. What's a compressor stall? A sudden loss of pressure and thrust inside the engine, which can lead to partial or total power loss. This would explain why the MD-11, even with two engines, couldn't climb. One was gone and the other was damaged. The videos also show something else. The aircraft tries to pitch up, increasing its angle of attack, but keeps falling. This suggests two possible explanations. Lack of thrust, due to damage in two engines. Structural damage to the left wing, preventing it from generating lift. Possible chain of events. The left engine catches fire. Flames affect the wing structure. The engine detaches with the pylon. Wing debris and fire reach the tail engine. The aircraft loses power and control and crashes. And all of this happened in a matter of seconds. This crash is reminiscent of the 1979 DC-10 accident. A similar model, also with three engines, experienced the detachment of its left engine during takeoff. That incident also ended in tragedy. The difference is that now, over 40 years later, technology should have prevented something like this. Are we looking at a design flaw that was never corrected? After the tragedy, alarms went off across the aviation industry. The aircraft involved in the accident, the McDonnell Douglas MD-11, had been at the center of an extremely serious incident. An engine detached during takeoff. And because of that, a historic decision followed. It was confirmed that all MD-11 aircraft had to be grounded. First, it was a recommendation from Boeing, the current owner of McDonnell Douglas's legacy. But soon after, it became a mandatory order from the FAA, the U.S. Aviation Authority. This wasn't a precautionary measure. It was a clear declaration. The MD-11 is not safe to fly until its structural safety is verified. The three main operators that still use this aircraft, FedEx, UPS, and Western Global Airlines, had to ground their entire fleets immediately. The crashed aircraft had been in service for over 30 years. It was manufactured in 1991. The three-engine design, one on each wing and one in the tail, was common in the 1970s and 1980s when engines were not as reliable. Three engines meant redundancy, but that need is long gone. Modern engines are so reliable that two are more than enough today. The MD-11 was no longer used for passenger flights. It had been relegated to cargo transport. But even in that role, it seems its time has come to an end. And all of this over one detail: the detachment of engine number 1. According to the NTSB's preliminary report, 37 seconds after applying takeoff power, the black box recorded a constant acoustic signal, a sound similar to a bell, alerting the crew to a serious anomaly. 25 seconds later, the recording ends. The aircraft was already on the ground. Subsequent analysis showed that the pylon of the left engine remained attached to the engine when it detached from the wing. This supports the theory that the failure wasn't between the engine and the pylon, but between the pylon and the wing. A structural failure in that critical connection caused the full engine separation. Now here's where things get more concerning. This engine isn't unique to the MD-11. It's the General Electric CF6, a widely used engine on aircraft like the Airbus A300, A310, A330, Boeing 747, 767, the C-5 Galaxy, and others. So here comes the unavoidable question. If the problem isn't the aircraft, but the engine, why has only the MD-11 been grounded? Why are other models with the same engine still flying normally? One possible explanation is that the failure lies not in the engine's design, but in how it integrates with the MD-11's wing. However, images of the damaged engine have started circulating, showing a very specific rupture in the turbine section. A fracture that could suggest an internal explosion. And if that's confirmed, then we're no longer talking about an airframe issue. We're talking about a core failure in the engine itself. This brings us to an important precedent. In 2016, a Boeing 767 suffered a severe fire in its left engine during takeoff. The engine, also a CF6, the aircraft was able to stop before liftoff, and there were no casualties. But the damage, especially in the turbine area, was strikingly similar to what we see now in the MD-11 crash. A massive rupture in the turbine section. Both engines are from the same manufacturer, same model, and the visible damage appears nearly identical. If the engine exploded from within, it may have released fragments that damaged the pylon mount. In other words, not a structural design flaw, but an internal mechanical failure that triggered a chain reaction. This leads us to an even more serious possibility, that the CF6 engine is hiding an internal fatigue issue or degradation that standard maintenance cycles have not yet detected. If that's true, the implications are huge, because this engine is still installed on dozens of active aircraft worldwide. But be careful. These are hypotheses, not conclusions. The official investigation could take months or even years. The engine was recovered within the airport, which will help in the analysis. The black boxes were also found, and despite the fire, they're designed to withstand extreme conditions. It's expected that the data will clarify the exact chain of events. Meanwhile, aviation communities and social media have started dissecting every frame of the crash videos. Users have pointed out that the left wing was fully engulfed in flames and missing the engine before final impact. They also spotted a flash in the tail engine just before the crash, further supporting the theory that it too was affected by fire or debris from the detached engine. Another observation being discussed. In several previous MD-11 accidents, the aircraft also ended up rolling over or crashing sideways. It's unclear whether this is due to the aircraft's design, mass distribution, or aerodynamic behavior under stress. But it's a repeating pattern that raises concern. All of this builds a dangerous narrative around the MD-11, a veteran aircraft with few units still in operation, now facing the possibility of permanent retirement. After the crash, the MD-11 has been officially grounded. Not by airline choice, not by voluntary recommendation, but by direct FAA order. No MD-11 may fly again until its structural safety is confirmed. This could mark the definitive end of the model, an aircraft that represented a transitional era in commercial aviation. It was designed for a time when 3 engines were required to cross long distances. Today, it's been overtaken by more modern, efficient, and safer 2-engine aircraft. It hadn't carried passengers in years. It was used strictly for cargo. But even in that role, airlines had begun seeing it as expensive to maintain, with limited spare parts and growing technical constraints. This accident may be the final argument needed to retire it for good. That's the big question. If the failure was in the MD-11 structure, then grounding it makes sense. But if the failure was in the CF6 engine, the implications are far more serious. That engine is still in service on dozens of commercial and military aircraft. If it's confirmed that the turbine exploded from within, as suggested by the damage photos, inspections won't be limited to MD-11s. It would mean grounding and inspecting aircraft like the A300, A330, Boeing 747, 767, and others. This could lead to massive inspections, temporary grounding of fleets, and major economic consequences. There's still no official conclusion. The FAA has acted specifically on the MD-11, but the investigation is still unfolding. What we do know is this. This crash has opened a dangerous door, one no one wanted to see open. The MD-11 has a history of rough landings, control issues, and minor incidents over the years. Some experts had already described it as a difficult aircraft to fly, especially during takeoff and landing. And now, with an engine literally falling off in flight, the safety of this design is seriously in doubt. It's very possible we've simply reached the end of its operational lifespan. And like many aging technologies, accumulated wear finally reveals hidden vulnerabilities. The black boxes have been recovered. They are expected to contain valuable data on pilot commands, registered failures, engine performance parameters, cockpit communication. But this analysis won't happen overnight. It may take weeks or even months, and the final NTSB report could take over a year. For now, we only have preliminary data, technical hypotheses, and many unanswered questions. Modern aviation is built on the analysis of every accident. Each tragedy becomes a technical lesson, and that's why, despite the media impact, air crashes are extremely rare. When one happens, it's global news. When none happen, aviation keeps operating quietly, with near-surgical precision. This case is no exception. Investigators aren't looking for blame out of punishment, but out of prevention. Every bolt inspected, every structure reinforced, might save lives in the future. This crash leaves us with many lessons about design, maintenance, technical limits, and how a chain of errors or failures can escalate in seconds. It also reminds us that technology ages, and that sometimes what worked for decades no longer has a place in the present. Is this the end of the MD-11? Everything points to yes, but the most important thing is what comes next. Knowing exactly what failed, why it failed, and how to prevent it from happening again. Everything that has happened so far raises more questions than answers. The MD-11 has been grounded. The CF6 engine is under scrutiny, and investigations are still underway. This accident wasn't just a tragedy. It could also mark the end of an era in modern aviation. If you're into stories where technology, history, and engineering intersect, subscribe to TechCurio. See you in the next video.